Okay, again, this is a pre-recorded video. If you can't make the lesson, Wi-Fi drops, whatever happens, here it is. So it's the gradient formula. This is what we're doing on Friday. Now, we already know this idea, I'm sure. Gradient is m because gradient starts with m. How do we work out gradient? We go rise over run. So let's start with a point like the point 2. Any guesses? What should we go? How about 3? Oh, let's go red. 3, and then we've got another point sitting up here. I'm going to go for this one being 7, and the y value, I'm going to say for argument's sake, is going to be 20. How about 30? What do you want to make it? And this is much more fun to do when you actually can give me a number, right? But let's say that it's going to be 33. How about let's go for something grand like that. And I asked you, what's the gradient? Well, you may have done it differently before. I know we've done some of these in class, and it kind of sticks how you do it, where you say, okay, well, gradient equals rise over run. And I must be honest, when I generally do it, I don't like to think of it as a formula after that. I just go, how far have we run, starting with the run from 2 to 7. So we go, okay, well, from 2 on the x-axis, how far have we run to get to 7? Well, we've run by 5. So therefore, this value here is, our run is 5. And how far have we risen? Well, we've gone from 3, and we're going up to 33 in our diagram, not to scale. So therefore, well, this distance is 30. So you go, cool, that's 30. And so our gradient's 6. But because the problems are going to get a bit more complicated, we're just going to put this step in between to say, well, how do we know that this distance was 5? We said that it was 7 minus 2 to give us the 5. How do we know this distance here is 30? We said 33 minus 3 to give us our 30. So in other words, we said y2, this y value minus this y value. So that's what we mean by y2 minus y1. And for the x values, we just said, well, 7 minus 2, so we subtracted the one x value from the other. Doesn't matter which way around you do it, as long as you're going the one point kind of minus the other point. So you can go 7 minus 2 and 33 minus 3. But don't go 7 minus 2 and 3 minus 33. Okay, so let's just see what little tidbits of information we've got here that are really a bit of revision. Gradient of any horizontal line is 0. Okay, that makes sense if we think of what gradient means. So here's a horizontal line. Gradient, how steep is that? Well, it's not steep at all. It's 0. So our gradient's 0. Or for every one step we go across, how far up or down are we going? We're not going up or down. Or we could say rise over run. Well, rise over run, well, no matter how far we run, we're never rising. So it's 0 over run. Well, that's always 0. Excuse me. Gradient of any vertical line is undefined. Okay, so let's do that on this side and say, well, what about a vertical line sitting here? It doesn't matter where. Well, gradient is rise over run. So rise over run. Well, we're never running. So this is 0. Well, we can never divide by 0, so therefore this is undefined. Parallel lines. Well, this thing's telling us that if we've got a line and we've got another line, the gradients are the same. Well, just think gradient is slope, and the slopes and the steepness are the same. And finally, we've got the perpendicular lines. I was thinking of the parallel lines, rise over run. They're the same kind of rise over runs, but let's not overcomplicate it. And for these, if we've got 2 lines and the one gradient is, say, 3, and the other gradient then will be negative a third. Let's not make it cross the x-axis. The whole point here is that this is a right angle. Then when you multiply the gradients, they equal minus 1. So the easy way to remember this is, well, let's say that this one here we said was 3. Then to find the other gradient, just go 1 over the reciprocal and change the sign. So if the one's positive, the other's negative. Makes sense. Look at the picture. The one's positive, then the other one's negative. Okay, and so you just, if it's a fraction, flip it over, change the sign. And we're going to have some questions. Determine the gradient. M equals rise over run. Just practice this to go, well, I'm going to go that minus that, so 5 minus 1, and then that minus that, 3 minus 2. Just check that your signs are kind of working out. 6 over 5. That seems about right. Yeah, right. 5 over minus 1, 5 minus 1, 3 minus 2. Yeah. I've got out my rhythm. I always like to start with the x's on the bottom. See, now it's got me confused. Okay, this one's similar. Given that, prove that they parallel. What does it mean if two lines are parallel? Gradients are the same, so you know how to do that. Just find the two gradients. Given, prove that they're perpendicular. So when you multiply them together, do you get minus 1? In other words, is the 1 the negative reciprocal? And then we've got some questions to do, which are that one. Which ones do I want? Given, prove that we're in a parallel, a perpendicular, and that's more than enough, right? Questions involving unknowns. That feels like a bit too much for now. But let's see. I'm recording this on Tuesday. By Friday, we're going to be like, yeah, we want to do lots of work. Okay, goodbye.